Ever wondered how files are shared over a network? Well, this is made possible through a protocol known as the Network File System, or NFS for short. Born out of the innovative minds at Sun Microsystems in the 1980s, NFS was designed as a distributed file system protocol to allow a computer to access files over a network as though they were right on its local hard drive. Over the years, NFS has established itself as a go-to standard for sharing files in networked environments, particularly within Unix and Linux systems. So if you've ever needed to share resources across multiple computers, chances are you've crossed paths with NFS. But what makes NFS so special? Well, it's all about the way it enables collaboration. Imagine you're working on a project with a team scattered across different locations. With NFS, you can all access and work on the same files without having to physically transfer them from one computer to another. This not only saves time, but also reduces redundancy and enhances flexibility. Now let's dive a little deeper into how NFS operates. At its core, NFS works on a client-server model. The server hosts the shared files, and the clients connect to the server to access those files. The server uses something known as exports to define which directories are shared, what access permissions they have, and which clients can access them. On the other hand, the client uses a mounting process to attach the server's shared directories to its own file system. Once mounted, these shared directories become accessible like local directories, allowing users and applications to interact with them through standard file operations. So, in a nutshell, NFS is a powerful tool that allows multiple computers to share resources and collaborate without physically transferring files. It's a testament to the power of networking and the possibilities it opens up for collaboration and resource sharing. So, NFS enables multiple computers to share resources and collaborate without physically transferring files. So how exactly does NFS work? Let's dive into the NFS client-server model to understand better. At the heart of NFS, there are two key players, the NFS server and the NFS client. The NFS server acts as the trusted custodian of shared files and directories. Think of it as a librarian overseeing a vast library of resources. The server defines the rules of engagement, dictating who can access what and how. It uses a mechanism known as exports to accomplish this. Exports are essentially rules that the server sets, specifying which directories are up for sharing, the level of access these directories have, and which clients are permitted to access them. On the flip side, we have the NFS client. The client is like a library member seeking to borrow a book. The client connects to the server, abiding by the rules set by the server. It uses a process called mounting to attach the server's shared directories to its own file system. Now, this mounting process is no hocus pocus. It's a straightforward operation that the client performs using a mount command or something similar. The client needs to know the server's network address and the export path, a bit like knowing the library's location and the book's exact shelf. Of course, the client must also have the necessary permissions to access the server's resources, akin to having a valid library card. Once the mounting process is successfully completed, the magic begins. The shared directories become accessible as if they were local directories on the client's system. This means users and applications can interact with them just like they would with local files. They can read, write, create, or delete files, subject to the permissions set by the server. In essence, the NFS client-server model is a well-choreographed dance, with the server leading and the client following. It's a dance that fosters collaboration and resource sharing across networked environments, reducing redundancy and enhancing flexibility. Once mounted, the shared directories can be accessed as if they're local directories. But how does a client connect to an NFS server? Well, let's dive into that. The process begins with what's known as mounting NFS shares. Think of it as attaching a foreign object to your local file system. To do this, the client uses a command, typically mount, to connect to the NFS server. This command attaches the shared directory from the server to a specified mount point on the client's system. Now, in order to mount successfully, the client needs to have the correct permissions. It's a bit like having a key to a lock. The client also needs to know the precise network address of the server and the export path, that is, the pathway to the specific directory being shared. It's like having the right key, knowing the door it opens, and the exact route to that door. Once the client has all this information and the mount command is executed successfully, the shared directory is attached to the client's file system. And voila! The client can now access this directory as if it were a local one. Now you may wonder what happens after the mount. Well, the client can perform standard file operations on the mounted directory. Yes, the usual read, write, create, and delete operations can be carried out, subject to the permissions set by the server, of course. It's like being a guest in someone's house. You can move around, use the facilities, even rearrange the furniture if you have permission. But you can't just knock down a wall or paint the living room pink. Well, unless you've been given those permissions too. Under the hood, the NFS protocol manages the data transfer between the client and the server. It's like a diligent butler, ensuring data integrity and security, making sure everything runs smoothly. And that's how clients can interact with shared directories just like they would with local files. So, whether you're sharing files across a small office network or connecting to a server halfway across the globe, NFS makes it as easy as if the files were right there on your local system. Did you know that NFS has evolved over time? Yes, indeed, the network file system has seen various versions, each bringing along unique features and improvements. Let's start with NFS v2. This was the original version, laying the groundwork for basic file sharing capabilities. It was somewhat rudimentary, utilizing User Datagram Protocol, or UDP, for transport. However, it had its limitations, particularly in terms of security and functionality. Then came NFS v3, an improved version that allowed for the support of larger files, introduced asynchronous writes, and provided better overall performance. A major change in this version was the introduction of Transport Control Protocol, or TCP. This was a significant enhancement that improved reliability, but the evolution didn't stop there. NFS v4 was a major upgrade. It expanded the capabilities of NFS significantly. This version brought better security with the introduction of Kerberos authentication, a robust protocol for verifying user identities. In addition to this, NFS v4 introduced stateful operations, file locking, and improved support for modern file system features. One of the notable changes in this version was the simplification of firewall configurations. NFS v4 consolidated operations into a single port, making it easier to manage network security. Each of these versions brought something new to the table. NFS v2 gave us the basic structure for network file sharing. NFS v3 improved upon this by increasing file size limits, introducing asynchronous writes, and switching to a more reliable transport protocol. Then NFS v4 came along and revolutionized the game, introducing features such as stateful operations and file locking. It enhanced security with Kerberos authentication and simplified firewall configurations, making it a more robust and user-friendly version. As you can see, each version of NFS brought significant enhancements, improving security, functionality, and performance. As NFS continues to evolve, we can only anticipate what the next version might bring. Why should we use NFS, you ask? Well, let's delve into the benefits of this powerful protocol that has been around for 4 decades and still holds a firm place in the world of network file systems. First up, file sharing. NFS stands out for its ability to allow multiple clients to access and share files and resources without duplicating data. This means we can save on storage requirements, making it a highly efficient solution for sharing files across a network. Think of it like a communal library where everyone can access the same books without needing to have their own copies. Next, we have cross-platform compatibility. NFS is like a universal translator for file systems. It works across different operating systems, making it a versatile choice for environments where you might have a mix of Unix, Linux, and even Windows systems. This ensures smooth communication and file sharing across diverse platforms, breaking down the barriers between different operating systems. Then there's centralized management. With NFS, you can centralize the storage and management of files, which simplifies backups and maintenance. It's like having a single, organized file cabinet instead of scattered folders all over the place. This centralization not only keeps your network tidy, but also ensures that data is managed effectively and efficiently. Finally, we have scalability. NFS is not a one-size-fits-all solution. It can be tailored to suit your needs, whether you're a small business with a handful of clients or a large enterprise with hundreds of users. It can support large-scale deployments, making it an excellent choice for businesses of all sizes. In summary, NFS is a powerful tool for sharing files over a network, offering flexibility, efficiency, and scalability. It's like a Swiss Army knife for file systems, providing a range of solutions for different needs. So next time you're looking for a way to share files across a network, remember the benefits of NFS and consider whether it's the right tool for your needs.